All right, so let's go over the review sheet here. So let's see. Which graph is the result of an even degree polynomial with a leading coefficient that's positive? So remember, even degree means both ends go up or both ends go down. So if the leading coefficient is positive, so that means that both ends are going to go up. So my keywords here are positive and even. So both ends going up would be letter F. Which graph shows as x goes to infinity, y goes to infinity? So that means the right side goes up. So I see that happening right here with letter F. Hang on, let me get my pointer. I haven't used this app in a while. I don't know, maybe on this one, this part right here. And then also this guy right there. Okay, and that's the only place I see it. So let's see, that was letter F as well. F and A. Which graph is a result of a polynomial with 3 unique real zeros? Well, I see that on letter A, 1, 2, 3. No place else do I see 3 unique real zeros. Just 3. I guess I should say only 3. So A. This one, like this one has 4, but anyway, which graph shows the graph of a quartic polynomial? So quartic, that's 4th power. That means that it has to have 3 terms. So that would be like B and F. See all your turn here, here, here. Okay, all right. Let's see, which graph is a result of a double root? So there's a double root happening right there. Which graph shows a cubic function? So a cubic function can only have up to 2 terms. So I'd say that's graph A. Now possibly D as well, because like this is turning and turning there, but it looks kind of flat to me. So, I mean, it probably is a cubic function, so we'll just put it in parentheses there, but A is really obvious. And like on the test, I wouldn't make something that was kind of like ambiguous like that. Which graph's a result of an odd degree? So the ends go opposite ways, and the leading coefficient is negative. So normally the odd degree, the right side goes up and the left side goes down. But if it's the first number leading coefficient is negative, then that's going to flip around. So that would be like letter C right here. It would also be like letter D. Quadratic, leading coefficient negative. That's definitely letter E, because it's a parabola pointing down. Number 9, odd degree, leading coefficient positive. So we're looking for this situation that I was talking about earlier. So that would be letter A. Number 10, a linear function with a leading coefficient that is positive. So a linear function means it's x to the 1st power, an odd number. So leading coefficient positive, that means we're looking for this situation again. But this line right here is going the opposite way. So that would be none. So I did say in the directions you could say none. Right, 11, which polynomial pictured has no real solutions, only imaginary, so no x-intercepts, so that would be letter E. All right, so in the bottom part, some true-false situations. So just be careful not to read too much into these and psych yourself out. If the degree of a polynomial function is 4, it must have 4 zeros. So on the answer key, I said false, but now that I'm thinking again, that's true. So yes, it has 4 zeros. I was thinking you had to have all real zeros, and so that's not true. They could be some imaginary, some real. But yes, they're all called zeros, even if they are imaginary. So if it's x to the 4th, there's 4 answers, basically. So number 13, the graph of a polynomial function may have multiple y-intercepts, and that is false. You can have multiple x-intercepts, like for instance, this one has 3, this one has 4, but there's only ever one y-intercept on a graph. Only one y-intercept on any picture ever. If there's an x under the radical sign, it's a polynomial. Nope, polynomials have to be like x x's to whole number powers. Remember, this would be x to the 1/2 power. So it has to be whole numbers, can't be negative exponents. That's a square root function. All right, the graph of a polynomial function may have exactly 2 x-intercepts. Sure. Look like a parabola. All right, a polynomial function must have real zeros. No, that is not true. You can have all imaginary zeros. Number 17, for the polynomial function, there is no y-intercept. So remember, the y-intercept is when x is 0. Well, so if the x is 0, that turns to 0, that turns to 0, but there's still -1. So that is false. If the degree is 3, it may have at most 2 turns. Yep, that's true. It's always 1 less turns at most. It could have only 1 turn, or no turns, doesn't matter. All right, so this guy. So remember, with these problems, we're going to start with going to Desmos. And so I have this in Desmos. And we see it with this red one right here. It's crossing at, looks like, -5 and 2. So there are 4 answers there to find, but -5 and 2 are my first ones. So -5, doesn't matter which one you do first. I got 1, 3, -1, 27, and -90. And then 2, right? So I bring my 1 down. 1 times -5 is -5. Get -2. Get 10. And then 9 when I add. And then get -45. And when I add these, let me see, 18, -18. Multiply, I get 90, and then 0. All right, then next one, bring down your 1. Get 2, 0, and 0. Add that up to 9, get 18, and 0 again. So notice how it drops down a level. All right, and so I took out 2 x's, so that means there's x squared and x right here. So I've just proven that -5 and 2 are the zeros, meaning x plus 5 and x minus 2 are factors, but I need 2 more. So I need to solve this equation. X squared, I don't need the 0x, plus 9 equals 0. So I think I can do square roots. Take away 9. X squared equals -9. Now, one important thing to note is that I could not see the zeros. So I know the graph is kind of small, but I only see 2 crossing places. So that means the other 2 must be imaginary. And look at this, when I take the square root, I get plus or minus 3i, because the square root of 9 is 3. So plus or minus 3i, x minus 3i, and x plus 3i. Doesn't matter what order. All right, down here, number 20. So number 20, let's go look at the picture. All right, so there's a picture. Looks like there's supposed to be 3 answers, and I can see them all. They're not too pretty. Only that one over there at 7 is very pretty. The other 2 are ugly decimals. So 7 I'm going to go with. So put my 7 in. 1, -2, -32, and -21. Nothing's missing. Bring down my 1, makes 7, adds up to 5, makes 35, adds up to 3, makes 21. So good. All right, so this is x squared and x. So I have to solve this. X squared plus 5x plus 3 equals 0. Well, I can tell that that doesn't factor. Nothing that multiplies to 3 makes 5 in the middle, so it can't factor. Which is also because the answers on Desmos were very ugly, right? So I'm not going to factor and get those ugly decimals. So when I can't factor. X equals fraction. Opposite of 5 is -5, so -b plus or minus a square root. We'll leave that in a second. The bottom is 2 times 1. 2 times a is 2. So let's do the discriminant. So I need b squared, which is 25, because 5 squared, minus 4 times a is 1, and c is 3. All right, so 25 minus 12 is 13. And so that's real. I saw the answers, but I just didn't know what they were. So there's my zeros. 7 and -5 plus or minus radical 13 over 2. Now for the next one, x minus 7 for my factors. Remember, for the ugly factors, we just put x minus, and then we put the 2 answers, -5 plus radical 13 over 2, and -5 minus radical 13 over 2. Sorry, that's kind of small. Okay. All right, last page here. So this is a function. It's kind of a funny looking one. It's not too polynomial-ish, but we can get the gist of everything. So some important things to note here. maybe I'll write down some important points here, like this point right here. That's a maximum, right? That's at negative 10 and 7. This guy over here, the end point, that's at negative 12 and 4. All right, this guy down here, negative 7 and negative 5. So I'm doing this because the questions are about increasing and decreasing. And so I'm going to need the x values of all these places. Here's a high point at 0, 5. And this guy at 4, 1. And then this goes off to infinity, comma, infinity. Okay, so we need increasing and decreasing. So let's do increasing as green. So I see this little section right here is increasing. This little section is increasing, positive slope, and this little section is increasing. So I have to name the x values of those green sections. So the first green section on the left goes from negative 12 to negative 10. And the next green section in the middle goes from negative 7 to 0. Remember, I'm using my x values. And the last green section over there goes from 4 to infinity. And then I need my decreasing area. So obviously those are the parts that are not increasing. So it would be like right in here and right in here. So when I do that, decreasing from negative 10 to negative 7. So what you're doing is you're saying it's decreasing between this x value and this x value. So that's the section. Negative 10 to negative 7. And then the next part, the next blue part, is from here to here. So look, 0 to 4. Okay, so for 23 and 24, I gave you some little choices here. It says, for which values is the function greater than 0? So that means positive, right? So when is this function positive? So let me erase this up here. So positive means you are above the x-axis. So when you are above the x-axis, that means that you are in this area right there. So when is this happening? So I see it happening. It's basically everywhere it's happening except for this section right here. So from negative 12 all the way to negative, what is that, 9, right? It's above the x-axis. And then from 4, negative 4, forever. So I would choose this section and that section of the graph. The only section where it's negative, so less than 0, is right in this section right here, where from negative 9 to negative 4. Negative 8. I think I made a mistake. Oh darn, it's supposed to be a 9. This section, this is supposed to be a 9 right here, and yeah, a 9 right here. I made a typo. All right, let's see. Use synthetic division to find f of 2. So remember, we just put a 2 here and do my synthetic division. Now this is missing x to the third, so 2, put a 0 for that, and then negative 10, 4, and 3. So bring down my 2. 2 times 2 is 4. Add that up. Multiply to 8. Add that up. Multiply negative 4, 0. Multiply to 0, 3. So that remainder right there is the answer. So f of 2 will be 3. So that means that when you plug 2 in for all these x's right here, if you were to plug that in, the answer would be 3. All right, and last one here, long division. So we put 5x plus 2 out to the side. Go over here. Nothing's missing, so 25x to the third plus 15x squared minus 3x plus 1. All right, so what makes 5x? How do you make 5x multiply to 25x to the third? So, well, I think I need a 5 and 2 more x's. So 5x squared is my choice. Now I multiply 5x squared by the 5x plus 2. So 5x squared times 5x is 25x to the third. 5x squared times 2 is plus 10x squared. Draw a line, subtract. These go away. 15 minus 10 is 5x squared. Bring down my minus 3x. To turn 5x into 5x squared now, I need another x. So times 5x is 5x squared. X times 2 is 2x. Line, subtract. These go away. Negative 3x minus 2x is negative 5x. Bring down my 1, so it's my last step. So how do I turn the 5x now into negative 5x? Well, all I need to do is multiply by negative 1. So minus 1. Multiply negative 1 by this, I get negative 5x minus 2. Subtract. These cancel. 1 minus negative 2 is 3. So my remainder is 3, and I put it over 5x plus 2. And that right there would be my solution to this division. Okay, that is it. I'll see you on Monday. Bye-bye.